Hi, and welcome to my presentation, how to predict the output of a CCPP power plant. In this project, I'm using machine learning libraries to predict the power output of an energy plant. So first, I'm importing these libraries. Then I'm loading the data, which is available as a CSV file into the notebook in a pandas data frame. And then for my information, I inspect the data by plotting the various features against the output. And for me, it looks like there's a clear relationship between temperature and vacuum, exhaust vacuum. The relationship between ambient pressure and humidity and the output is unclear to me. Therefore, I'm running a lasso regression against this data using alpha parameter of 1 and a stronger value of 10 to see if there are any features that will vanish. And yeah, as one can see, so already with alpha parameter of 1, the ambient pressure had a very small coefficient, and by using an alpha value of 10, not only the ambient pressure parameter is vanishing, but also the humidity parameter vanishes. Therefore, I decide to use exhaust vacuum and temperature features for the training and drop the other parameters. And for the training, I first need to do this train test split, for which I use a test size of 20%. And I'm running this. And you see the shape of the training set and the test set. And now I'm training a linear regression model and a random forest regression model. For this, I use previously created train data. I use a cross-validation parameter of 10, and for scoring, I use the mean absolute error and the mean squared error on both models. Let me just quickly run this and okay, we can already see that the random forest regressor is performing better than the linear regression, and that's why I use this random forest model as a best model. So random forest is better on both metrics, mean average error and mean squared error. And now I evaluate the best model on the test set. So I'm using now the test set data for prediction and now determine the mean absolute error and the mean squared error again. And you can see that mean absolute error and mean squared error are very similar. So that's the best model performs very well also on the test set. For visualization, I also plot the predicted value versus the actual values in this diagram. Since I was unsure about the feature selection, I've created a variant of this notebook where I use all parameters for training. And just for your information, here we can see that the mean absolute error and the mean for the two models actually smaller. So actually using all features is even better, improves the models a bit. And also on the test set, I can see an improved result if you compare value of 271 versus 2.3 on the mean average error. And again, here's the plot for that. Yeah, so that's all what I want to show. My proposal would be to use the random forest regressor model and with all features to predict the output of the CCPP. Thanks.